Welcome friends to Maths for IIT. Today we are going to discuss one topic of integral calculus, and the topic is how to compute area enclosed by a curve or curves. In order to calculate area enclosed under a curve or curves, definite integral is used, and there could be three situations which can be asked in examination. This particular topic is particularly very important for students who are preparing for IIT joint entrance examination, both main as well as advanced, because from this topic questions are asked in IIT JEE. Other than that, this topic is also important for students who are planning to appear for joint admission test for MSc conducted by IITs, that is JAM 2020 or beyond, because this is also part of the syllabus of IIT JAM. Now, there could be three situations of area under a curve. The one situation could be that you are given just one equation or one function, and you will be asked to calculate area enclosed by either of axes, which is either area enclosed by that curve along with the x-axis in a given boundary limits, which is within a given bound, or you can be asked to calculate area enclosed by that particular function along with the y-axis, again within a given bound. There could be a third situation as well, where you will be asked to actually compute area enclosed by two curves in a certain bound, or an area enclosed by two curves at the point of two intersections. Okay. In order to calculate the area bound by a function or a curve and x-axis, what we do is we actually do a definite integral of the function from a given bound a to b, and we calculate that. In case of area where we need to calculate bound by two curves, actually what we do is we subtract one of them from the for another one, and then do the integral within the given bound. Okay. Now, in order to decide which should be deducted from what we you need to do is that you need to actually be hands-on on plotting graph, and you need to see which of them uh, is a bigger function. And in order to get a positive result, you should actually subtract the lower one from the bigger one. But you need not be worried about this, because area anyway is a scalar function. Even if you get a negative computation, that should actually not be a problem. You can just make it positive and write the answer. For a better understanding, what I have done is I have taken this particular equation, which is fx is equal to x plus sine x minus 3 oblique 2, which is this red graph shown here on the screen. And we have to compute area enclosed by this particular function or this particular line along with x-axis from a bound 5 to 10. Okay. And in order to compute that, we have to simply integrate the given equation from bound 5 to 10 and get the answer. And by doing so, we get the answer as 30 units. Like you can see, x plus sine x minus 3 oblique 2, when we integrate with respect to x, we get x square oblique 2 minus cos x minus 3 oblique 2x from, and we apply the bound from 5 to 10, and therefore we get this particular answer, and the answer is 30 units. Now we take a second case where actually we need to find out the area enclosed by two curves, and I have kept the first equation as it is, which is y is equal to x plus sine x minus 3 oblique 2, and I have taken a second equation, y is equal to cos x plus 2. Now, one important thing I wanted to state that uh, to to get the area between the point of intersection of these kind of curves could be actually beyond the scope of 10 plus 2 syllabus. Usually, if you are asked such a trigonometric function, you will definitely be given a bound, either along with along y-axis or x-axis to compute, and you need to simply apply that bound. You should not actually go into computing the area, computing the point of intersection for these two curves. Okay, so in order to do that, now we have to compute area enclosed by these two curves from the bound A to B, for example. And in this case also what we are doing is we are computing the area between bound 5 to 10 units. Okay, so what we have to do is we have to subtract gx from fx, which is the function given here. And by doing so, we get this particular equation, which is x plus sin x minus cos x minus 7 oblique 2. And we need to integrate this particular equation with respect to x using definite integral with bound lower bound 5 and upper bound 10. By doing so, we get this particular equation, and now we apply the bound a is equal to 5 and b is equal to 10 to get our answer as 20.7 units. Okay. I hope you understand this. In case you have any query, kindly do make your comment in the comment box in the below. This video will be uploaded on YouTube. You can make a comment there. I will try to come back to you with clarification of your doubt. Now we take a simple parabolic equation with a 2 point of intersection area, and these two equations we need to compute. The function fx is x square minus 3x plus 2, which is a parabola, and the second function is y is equal to x plus square root of x. Now area covered between these two curves will be computed between 2 points. In the first case, we have taken points of intersection of these two curves, which means area covered under this particular area we need to compute, which is shown in the red here, which is actually from one point to one point of intersection to another point of intersection. Incidentally, these two curves intersects only at two points, which means the equation, while we use both the equation to find value of x, we get only two real roots of x. And we go applying the formula in the same way. In this case, actually, we have to compute the area in the direction of x. Then we will have bound as 0.382, which is the first point of intersection and x value, and 4. 4 is again at the second point of intersection in the direction of x. And we need to do the integration from 0.382 to 4 in order to. By doing so, we get this particular equation shown here, and by applying the definite integral, we get the answer as 25.3 units. Now we take the same two equations and we find the area enclosed by a bound, which is x is equal to 1 and 4 and x is equal to 4. Although 4 is just the second root of x, but we will try to find out what is the area which is covered between x is equal to 1 and x is equal to 4. Now, if you look at the graph which is given here, we need to find out the area of the highlighted portion, highlighted portion in red. This means we don't have to integrate this from one of the root, rather we have to integrate this from x is equal to 1 to x is equal to 4 in the direction of x-axis to find the area. Now same simple rule will be applied to find the area, and by doing so we get area as 23/3 units. Now I take two trigonometric functions and try to find out the area enclosed by these two functions. Now the trigonometric function are fx is equal to sine 3x and gx is equal to cos x plus 1, and we have to find area enclosed between these two curves from a bound which is 0 to 2 along with x-axis. Means from origin till 2 unit in the direction of x, we need to find the area enclosed between these two curves. And the rule will be exactly the same without any change. And we get the answer as 2.89 unit. Now for 10 plus 2 students, they need not worry about getting at what all points these two equations are going to intersect each other, because trigonometric functions and the curve may actually intersect each other at infinitely many points. And so you will be given a bound to compute the area. Now we take a simple curve of y is equal to x to the power minus 3, and we apply bound a to b to compute area. In this case, a is x is equal to 1 and b is x is equal to 2, which means we need to find the area enclosed by this curve and x-axis between these 2 points. And simple rule is to integrate this from point 1 to point 2 and get the answer. We get the answer as 3/8 units, which is highlighted in green. Exactly, you can also be actually asked to compute area along with y-axis and the curve. In that case, what we need to do is we need to actually invert the equation and do the integration with respect to dy in uh, y direction. And in this case, this has been integrated uh, from point 0.5 till 2, means zero point 0.5 unit till 2 unit in the direction of y. And we get this equation, and after integration we get this particular equation where we need to apply the bound, and we get answer as 1.4355 units, and the area is has been highlighted in blue. Similarly, I am leaving one question to you to compute, which is actually this is the same equation that we used just a few slides back. Fx is equal to sine 3x and gx is equal to cos x plus 1. The equations is given here. Now you need to compute the area between the first 2 points of intersection in the direction of x. And these points are x is equal to 2.228 and x is equal to pi. This I am leaving up to you to find out the area, and you have to apply the same rule and find out the area. Okay. What you have to do is you have to subtract cos x plus 1 from sin x, and apply the integration in with respect to x in the with the bound lower bound of 2.228 and upper bound of pi. The area which has been asked is this area which is highlighted in blue boxes here. You have to find this area. Thank you for watching my channel. Do subscribe to the channel and share with your friends. I'll be back again with another video. Thanks a lot. Bye bye.